You know how it feels when you're driving on the highway and your car is just packed to the absolute brim?
Oh, yeah, like moving day.
Right, exactly. The trunk won't close, the roof rack is groaning, the engine is whining, and the RPM needle is just buried in the red. And if you have to brake hard, or like if a tire blows, that vehicle simply cannot handle the sudden change.
No, it's completely maxed out.
Exactly. And that redlining engine, that is the exact state of global human infrastructure this morning.
Yeah, that's a really good way to put it.
I mean, from burning power grids in the Midwest to AI servers literally running out of space in 48 hours to exhausted World Cup athletes, the systems we rely on are currently being asked to carry maximum strain with absolutely zero room for failure.
Right.
So welcome to the Deep Dive. Today, we're taking the massive stack of intelligence from the July 21, 2026 news brief and unpacking the defining narrative of the day for you. We're calling this one capacity pressure.
And what's fascinating here is how deeply interconnected this pressure has become across entirely different domains.
Right. It's not just one thing.
No, not at all. We are not just looking at isolated incidents in technology or, say, the weather. When we analyze the digital networks, the physical environment, geopolitical supply chains, and even our leisure time, a really clear pattern emerges.
Every system is just pushed to the edge.
Exactly. Every major human system is operating at the absolute limit of its design.
Okay, let's unpack this, starting with, the most literal form of capacity pressure, which is the physical electricity grid.
Right, the power grid.
Right now, there's a regional grid operator that serves 14 central U.S. states, and they're waving a massive red flag.
A really big one.
Yeah, they're warning of imminent rolling blackouts. And what stands out in the data is that this isn't just, a simple case of summer heat.
No, it's much more complex than that.
It's extreme temperatures colliding with sustained industrial demand, plus the sudden explosion of new AI data centers hitting the grid, all at the exact same time.
It creates a perfect storm, really, of consumption testing, an aging, rigid system. And storm is the operative word here, because while the electrical grid is straining under the weight of human demand, the natural environment is simultaneously fracturing.
Yeah, the numbers from Ontario right now are just staggering.
They really are. There are 190 active wildfires burning up there, consuming 735,000 hectares.
Which is what, like 1.8 million acres?
Yeah, roughly 1.8 million acres. And that fine particle smoke is drifting thousands of miles across states from Wisconsin all the way to Ohio.
Creating severely unhealthy air for millions of people. And it feels contradictory, seeing record-breaking, drought-driven wildfires in Ontario wiping out millions of acres, while at the exact same time down south, the Gulf Coast is bracing for a tropical system.
Right, threatening coastal surge and torrential flash floods.
Contaminated with raw sewage, too. On the surface, fire and flood look like opposite problems, like a glitch in the Earth simulation.
Yeah, it does look like a glitch, but physically these aren't opposites at all.
They're feeding off the exact same mechanism, right?
Exactly. They are two sides of the same thermodynamic coin. The scientific reality of a warmer atmosphere is that it acts like an enormous sponge.
Sponge, okay.
Yeah, so a warmer atmosphere bakes the moisture out of the vegetation on the ground, creating the perfect dry kindling for the massive wildfires we're seeing.
But that evaporated moisture doesn't just vanish.
Right, exactly. Warmer air inherently holds a greater volume of water vapor than cooler air. So when that atmospheric sponge finally gets squeezed by a pressure system, it releases highly concentrated, devastating storms.
Like the ones currently threatening the Gulf Coast. Yeah. So the sponge just aggressively moved the water from one geographic extreme to another.
You've got it.
And this dynamic leads directly to a crucial emerging concept in the medical field that we're seeing in the intelligence today, which they call infrastructure medicine.
That's a huge shift in how we view healthcare.
It really is.
Yeah.
We traditionally think of healthcare as doctors, hospitals, prescriptions, but basic infrastructure is now the primary health protection.
Yeah.
Like, if you live in Ohio breathing that wildfire smoke, clean air access through N95 respirators or portable HEPA filters is no longer like an environmental preference.
No, it's a literal medical necessity.
Right, to prevent cardiovascular and respiratory crises.
Which brings us right back to the vulnerability of those 14 central states facing rolling blackouts. Reliable electricity is no longer just an economic metric or about staying comfortable with AC.
It's about keeping people alive.
Exactly. Consider the millions of people who depend on refrigerated medications like insulin, or those utilizing powered mobility equipment, home dialysis, oxygen machines.
When the grid fails, those individuals immediately flood local hospitals.
Right. Not because they have a new illness, but because they simply need an electrical outlet to survive. Hospitals are being forced to constantly audit their backup power plans because the grid itself has become a public health liability.
That transition from physical power grid to medical necessity is such a stark reality check. But to truly understand this strain, we have to look at what is actively devouring so much of that power.
The digital side.
Here's where it gets really interesting, because we casually talk about the cloud like it's this infinite invisible magic up in the sky.
Right, just floating up there.
But the operational data today regarding Moonshot AI proves that the cloud is really just heavily air-conditioned server farms bound by literal plumbing, concrete, and thick power cords.
It is incredibly physical and very finite. Moonshot AI just had to completely pause new subscriptions for its latest Kimi K3 model.
And what makes this extraordinary is the timeline. They had to trigger this pause within 48 hours of launching the product.
48 hours.
That scale of consumption is genuinely alarming. Launching a major tech product and turning away paying customers 2 days later, it points to a massive miscalculation of demand versus physical hardware.
It really does. The overwhelming demand pushed their available GPUs, their graphics processing units, to their absolute operational limits.
And this isn't just about more users, right? It's about how the AI is being used.
Exactly. This intense strain is driven by a fundamental shift in how we actually use AI now. We've moved past simple chatbot text interactions where you ask a single question and get a static paragraph back.
The industry is shifting toward agentic coding.
Right.
And the way I understand agentic coding, the user isn't just asking a question anymore. One single prompt turns the AI into a sort of autonomous project manager.
Yeah, that's exactly what happens.
It plans a task, reads necessary files, generates the code, tests that code in a sandbox, corrects its own errors based on those tests, and then reports back.
And that involves CRU'd operations: create, read, update, delete.
So one prompt from a user might equal a dozen or more massive complex model calls on the server side, creating an exponential compute load.
That internal looping is precisely what devours compute capacity. A single user is suddenly commanding the processing power of an entire engineering team.
Wow.
And if we connect this to the broader financial picture, the entire AI industry is being forced to shift its focus from promise to proof.
Because investors are realizing that theoretical capabilities do not matter if the servers physically melt trying to deliver them.
Right, exactly.
The intelligence notes that Moonshot has raised over $5.5 billion and is looking at a valuation near $30 billion.
That's a massive valuation.
It is. But as they prepare for a possible Hong Kong listing, the market is scrutinizing their infrastructure capacity and revenue durability, not just their benchmark scores.
Which is why we saw Asian tech markets, like South Korea's KOSPI index, jump nearly 5% today.
That capital is actively hunting for companies that manufacture the essential physical AI infrastructure, right?
Yeah, the cooling systems, the power regulators, the memory chips. Investors want the hardware makers rather than those just making distant promises about software capabilities.
Because it's become a global arms race defined by massive physical constraints. Like, look at Alibaba.
Right. Alibaba just previewed a 2.4 trillion parameter model, the Qwen 3.8 Max.
2.4 trillion.
Trillion, yes. And to put that in perspective, every single one of those 2.4 trillion parameters requires active memory and computational power just to load into a server, let alone run active inferences for millions of users.
That is just mind-boggling.
It is. Chinese developers are pushing the boundaries of software, but they're facing a severe operational disadvantage. They have restricted access to the most advanced American-designed chips capable of handling that load efficiently.
Which makes hardware manufacturing the ultimate choke point.
Exactly.
It isn't a shortage of brilliant software engineers, it's a shortage of silicon. So ASML, the company that builds the immensely complex, extreme ultraviolet lithography machines required to manufacture these advanced chips, they are planning a 30% expansion in their manufacturing capacity over the next 2 years.
And 2 years is actually a highly compressed timeline when you consider the sheer complexity of those machines.
Right, they're not just building toasters.
Not at all. An ASML lithography system contains hundreds of thousands of components, utilizing lasers that vaporize tin droplets to create light wavelengths capable of printing circuits mere atoms wide.
You cannot just build a new factory overnight to ease this global choke point.
No, you really can't.
And nations are actively looking for ways to bypass these physical hardware bottlenecks altogether.
Oh.
Look at India. They just successfully completed their Vikram 1 space mission, placing customer payloads into an orbit 450 kilometers above Earth.
A huge milestone.
Yeah, and what stands out to me isn't just the successful orbit, but the method. They utilized solid fuel stages and 3D printed engine components.
That methodology is absolutely crucial. Solid fuel is stable and ready to launch, bypassing the highly complex, volatile liquid fueling infrastructure that causes so many delays in traditional aerospace.
And the 3D printing.
Right. By utilizing 3D printing for engine components, India is completely bypassing the massive global backlog in traditional aerospace forging and casting.
They're building an independent, reliable physical infrastructure to capture dedicated launch schedules without relying on strained global supply chains.
Exactly.
So what does this all mean? That extreme reliance on highly specialized physical hardware leads us right into a terrifying vulnerability.
It really does.
Because you can manufacture all the advanced silicon or aerospace components you want, but if the physical trade routes required to move energy, materials, and goods are active conflict zones, the entire system grinds to a halt.
Yeah, looking strictly at the operational realities reported on the ground today in the Middle East, the physical bottlenecks are quite literally matters of life and death.
And just to be completely clear for you listening, we are strictly reporting the facts as laid out in the intelligence brief today regarding the United States and Iran.
Exactly. No political sides being taken here. We are just looking at the reported data.
Right. So the human toll of the conflict between the U.S. and Iran is already severe. Mediators are actively pursuing a 10-day ceasefire, but the brief reports that 17 American service members have been killed during the wider conflict, with more than 420 wounded.
And the global financial markets are reacting to this instability in real time, but there's a strange dichotomy in how they react versus the physical reality on the ground.
Right, because oil prices actually dropped slightly on the mere prospect of this ceasefire. Brent crude fell approximately 1.1% to about $88.26 a barrel.
Which sounds like relief.
But domestic U.S. gasoline remains over $4 a gallon, which is a sustained 30% increase since the conflict escalated in February.
This market phenomenon is best described as conditional relief. Financial markets are statistical entities, you know?
Yeah.
They can price in a diplomatic ceasefire instantly, buying assets on the possibility of de-escalation, while still retaining complex financial derivatives to protect against a sudden failure of those talks.
But a ship captain cannot operate on conditional relief.
No, they can't.
The financial market might price in a pause in milliseconds, but the news brief details that a tanker in the Strait of Hormuz was just struck by an unknown projectile, forcing the crew to abandon the ship in a lifeboat.
It's terrifying.
A shipping operator isn't going to look at a ticker symbol on a screen to decide if it is safe to sail millions of barrels of crude oil. They require physical, ironclad proof that the waterway is secure.
The physical reality severely lags behind the financial reality. Ship crossings through Hormuz are declining even further because insurers simply won't underwrite the risk.
And crews refuse to sail without clear evidence of safety. Rightfully so.
Right. And compounding this, Yemen's Iran-aligned Houthis are threatening a naval blockade against Saudi Arabia.
This threat risks spreading the disruption from Hormuz directly into the Red Sea.
Exactly, effectively placing both primary and alternate global energy routes under extreme duress.
It is literally choking the physical movement of the world's energy.
I categorize this as the delivery problem.
The delivery problem. Okay.
Yeah, generating energy or manufacturing a product is only half of the battle. For a perfect example outside of the conflict zone, look at the energy data coming out of China.
Okay, what are they doing?
They are currently building more large-scale wind and solar capacity than the rest of the world combined.
That is massive generation.
It is. Yet, wind and solar account for only about 20% of the power actually transmitted through their ultra-high voltage network.
Wait, really? Only 20%?
Yeah, coal still supplies 42%.
Because producing green energy in remote areas doesn't matter if your grids, your transmission lines, and your storage facilities cannot reliably deliver it to the coastal demand centers when it's actually needed.
Precisely. The transmission is the bottleneck, echoing the exact same problem as the AI data centers and the U.S. electrical grid. Everything is ultimately bottlenecked by the physical delivery mechanism.
And political leaders worldwide are feeling the intense weight of this transmission and supply strain. Look at Britain.
Yeah, the new prime minister there, Andy Burnham, is preparing initial measures intended to ease a severe cost of living crisis.
But the operational reality he faces is a delicate balancing act. Again, strictly looking at the intelligence reporting here, he has to weigh immediate household financial relief against persistently expensive energy imports, mandatory defense commitments, and highly nervous bond markets.
Bond markets that will severely punish any over-leveraged government spending.
Exactly. And looking at the political landscape in the U.S., again, just stating the facts from the brief, it notes that a super PAC, aligned with President Trump, reported having over $400 million available for the approaching midterm election campaign.
A massive war chest.
Huge. That massive financial reserve underscores the sheer volume of resources being marshaled to influence a political system that is managing its own extreme form of capacity pressure. The stakes and the required capital to actually play the game are incredibly high across the board.
Whether the domain is military, electrical, financial, or political, these macro systems share the exact same defining characteristic right now. They are being asked to carry more strain with less margin for failure.
And having mapped out these massive macro systems, the power grid, the AI servers, the global shipping lanes, the political arenas, it is vital we bring this down to the human level.
Right, how this actually affects people.
Because even in our escapes, the things we do for entertainment, we are pushing right up against the absolute biological limits of human endurance. Let's look at the World Cup.
Spain's victory celebrations are continuing after a grueling 1-0 extra time win over Argentina.
A 106th-minute goal by Ferran Torres delivered the championship, right? Which extended Spain's international run without defeat to 38 matches.
It is an incredible athletic achievement.
It is. But beneath the celebration is a massive pressure cooker. This tournament was significantly expanded to 48 teams.
It featured 104 matches across 16 host cities.
And spanned 39 days of competition. Just like Moonshot AI running out of available server space, global sports leagues are running out of calendar days.
Yeah, that's a great comparison.
They're trying to cram more matches into the schedule than human muscle and ligaments can physically recover from.
If we connect this to the bigger picture, the brief highlights that this immense scale generated extraordinary commercial revenue, but the hidden cost was intense player fatigue.
Because these athletes have to return quickly to their domestic clubs to prepare for regular seasons.
Leaving virtually no time for cellular repair and physical recovery, European leagues and clubs are likely to become increasingly combative about this international scheduling.
Well, they're the entities that ultimately absorb the financial and competitive cost of these fatigue-induced injuries.
Exactly. Institutions are trying to scale entertainment output faster than the human body can adapt.
It sparks a necessary debate over whether commercial ambitions are completely overtaking the health of the athletes and the actual quality of the sport.
We can categorize this cultural microtrend as format expansion. Institutions are trying to add teams, investors, and events much faster than they are adding time.
And time is the one strictly non-renewable resource.
Exactly. Consider the cricket data in today's brief. The 100 cricket competition is beginning with new owners and a redesigned commercial structure.
They're explicitly adopting much shorter formats to compete for fragmented audiences, right?
Yes. They recognize that people's attention spans and available leisure time are also operating at maximum capacity.
We see this capacity strain happening in our downtime, and it's heavily reflected in our work environments as well. The data from Compass Group, which provides massive workplace food services, reported a 7.1% organic revenue growth in workplace dining.
Which is fascinating. That data point reveals something deeply interesting about the modern worker's equilibrium.
How so?
Well, despite domestic gasoline staying above $4 a gallon, which makes commuting a significant financial burden, and despite the obvious lifestyle appeal of hybrid work, office attendance remains strong enough to drive significant growth for corporate dining.
So employees are finding a new, highly pressurized equilibrium. They are absorbing the high cost of the commute to maintain their output and visibility at work, grabbing lunch in the company cafeteria to maximize their time, and then trying to recover with shorter, more condensed entertainment formats at home.
We are running hot at every single level, from the AI code we write, to the oil we ship, to the games we play.
It is the defining signature of this moment in time. Systems are stretched, taut.
Completely taut.
Pulling all of this together for you, the hidden narrative of today's intelligence is undeniable. We started by looking at a 14-state power grid on the verge of rolling blackouts, squeezed by extreme weather and the massive energy appetite of new AI data centers.
We saw a multi-billion-dollar AI startup literally run out of computational pipe space in 48 hours because complex agentic coding multiplies compute load exponentially.
We looked at burning tankers in the Strait of Hormuz physically choking the flow of global energy, and we watched exhausted World Cup champions pushing the limits of human physiology for 39 straight days to satisfy commercial expansion.
The global system, whether electrical, digital, geopolitical, or biological, has zero excess capacity left.
None.
Every structure we have built is optimized for maximum output, leaving absolutely no margin for error or disruption.
Which leaves me with a thought that has been nagging at me since we first opened this stack of intelligence.
What's that?
We have spent the last few decades optimizing our entire civilization for maximum efficiency and maximum profit. No wasted space, no idle servers, no slack in the global shipping schedule, no extra inventory sitting in warehouses. Right. But if every single system is running at 99% capacity just to maintain a normal Tuesday morning, what happens when we face a truly unexpected massive global shock? Is our absolute obsession with efficiency actually destroying our foundational resilience?
That's the million-dollar question. A redlining engine might win the race in the short term, but it is always one bad pothole away from tearing itself completely apart.
Think about that the next time you're on the highway listening to that engine hum. Thank you so much for joining us in this deep dive into today's intelligence. Stay curious, keep questioning, and we'll see you next time.